The government called it a public health hazard. The cooling industry called it primitive. And 3 states quietly passed ordinances making parts of it illegal within city limits. Not because it stopped working, but because it worked too well. One Amish community in Lancaster County used this system through the summer of 1976, the hottest summer on record at the time, and not a single family paid a cooling bill. Here is what they knew that nobody was supposed to remember. Hi, my name is Robert, and this is Forgotten American Nature. The system. Nobody named. Here's the first thing you need to understand. The Amish did not call this a system. They did not call it anything. They built houses the way their fathers built houses. Going back through generations of German and Swiss Anabaptist communities who had been figuring out how to stay alive in hot summers since before the United States existed as a country. What they had was not a single trick. It was a complete understanding of how heat moves, where it comes from, how to block it before it enters a structure, and how to pull it out once it gets in. Every piece worked together. You cannot pull one piece out and call it the method. That is what modern survivalist content gets wrong, and I say that as someone who has watched approximately 400 videos about putting a wet towel on a fan. The Amish did not need a patent. They needed a good north-facing hillside and the knowledge their grandmothers handed down. Let us start at the foundation, literally. Number 10. The thermal mass wall. Before a single window was placed, before a door was hung, an Amish builder was already managing temperature. And it started with the walls. Stone, brick, packed clay, dense materials that do something no modern fiberglass insulated stud wall can do. They absorb heat slowly and release it slowly on roughly a 12-hour delay. That delay is everything. When the sun hammers the west face of a stone wall at 2 in the afternoon, that wall absorbs the heat rather than transmitting it immediately inside. By the time that heat reaches the interior surface, it is 10 or 11 at night. The air outside has already cooled. The heat bleeds in at midnight when the windows are open, and the night air pulls it right back out. Amish builders oriented their homes with the long axis running east to west, presenting the smallest face to the brutal afternoon sun. Deep roof overhangs blocked the high summer sun completely. This was not guesswork. It was calculated, generation by generation, a father showing a son where to set the rafter. Modern homes face whatever direction the street happens to run. The west face gets full afternoon sun with nothing behind it but half an inch of sheathing and some fiberglass bats. And then we wonder why the air conditioner runs for 6 hours every afternoon. Your great-grandmother's stone house did not wonder. It already knew the answer. Number 9. The root cellar as a living space. Now here is where it gets interesting. A lot of people are going to say, wait, I thought the root cellar was just for storing potatoes. It was. And it was also the most sophisticated passive cooling chamber available to a rural American family for 200 years. The Amish and many frontier families did not just store food down there. They lived down there. In summer. Not full-time. Not sleeping on the earthen floor next to the turnips. Although honestly, some summer nights that sounds appealing. But the summer kitchen in many traditional Amish and Germanic farmstead designs was located at least partially below grade. Sunk into the earth 4, 5, sometimes 6 feet, with a stone floor, thick earthen walls on 3 sides, and a small high window on the north face to admit light without admitting solar heat. The earth below the frost line maintains a temperature between 50 and 58 degrees Fahrenheit year-round. Not affected by seasons. Not affected by whether it is 90 degrees outside or 20. The earth is a massive thermal battery, and at 6 feet of depth, summer might as well not exist. A room built into that earth is not air-conditioned. It is earth-conditioned. There is no compressor. There is no refrigerant. There is no service technician coming out on the hottest day of the year to tell you the capacitor blew, and the part is back-ordered until Tuesday. I am not speaking from experience. Fine. I am speaking from experience. Amish families prepared summer meals in this space, stored dairy here, and rested during the brutal midday heat from June through August. Modern building codes now require habitable rooms to meet ceiling height, window area, and egress requirements that effectively prohibit below-grade living spaces without expensive permittings. Earth contact construction is specifically excluded from residential insulation standards in several states. The earth itself, the most effective thermal regulator on the planet, does not qualify as insulation under most American building codes. I will let you sit with that for a moment. Number 8. The sleeping porch. I want to tell you about my great-aunt Edna. She was not Amish. She lived on a farmhouse in southern Ohio. She slept on her sleeping porch from the 1st of May through the middle of September every single year, until the county told her the screen was not up to code and the structure needed a permit. She was 87 at the time. She told them what they could do with their permit. That is a different story. The sleeping porch is one of the great lost architectural features of American residential design. Before central air reached middle-class homes in the 1960s, houses across the South, the Midwest, and the Mid-Atlantic were routinely built with screened elevated porches on the east or north face of the structure, specifically designed as sleeping quarters for the summer months. The logic was perfect. Hot air rises. A sleeping person generates significant body heat. On the ground floor inside a closed house, that heat accumulates through the night and sits on you like a wool blanket. On an elevated, cross-ventilated, screened porch open on 3 sides, that heat disperses immediately into the moving air. A sleeping person on a good sleeping porch in a light breeze cools themselves through convection all night long, waking rested and dry rather than pasted to a damp sheet in a 68-degree room that costs $40 a night in electricity to maintain. Amish farmhouses of the traditional design incorporated this directly into the structure. The second floor of many Lancaster County farmhouses featured deep, inset porches under the main roofline, screened on 3 sides, oriented to catch the prevailing southwest breeze and exhaust heat toward the east. The orientation was not accidental. Every Amish builder knew which way the summer wind blew because knowing which way the summer wind blew was part of building a house. It was not a detail, it was a foundation. Modern zoning codes restrict screened porch enclosures as habitable space in most jurisdictions. Homeowners associations across the Sun Belt, which is frankly where you need a sleeping porch the most, routinely prohibit exterior screening modifications. In some Florida and Texas communities, adding a screen enclosure requires Architectural Review Board approval and engineering drawings stamped by a licensed professional. Your great-grandmother slept cool for 60 years on a porch she built herself in an afternoon. Her granddaughter now needs a licensed engineer and a homeowners association waiver to do the same thing. Number 7. The whole house stack effect. Hot air rises. This is not a folk saying. This is thermodynamics, and Amish builders weaponized it. The whole house stack effect is a passive ventilation principle that uses the natural buoyancy of warm air to pull cool airs through a structure from the lowest openings to the highest, creating continuous airflow without a single fan, a single motor, or a single watt of electricity. Here is how it works. You open low windows and vents on the shaded north side of the house at ground level or just above. You open high vents, ridge vents, cupola vents, or gable vents at the peak of the structure. Hot air inside the house, which is lighter than cool air, rises toward the peak and exits through the high vents. As it exits, it creates a slight negative pressure in the lower portion of the house. That negative pressure draws cool outside air in through the low north-facing openings. The house breathes. Cool air in at the bottom, hot air out at the top. continuously, silently, free. Traditional Amish farmhouses and bank barns, the ones you see all over Lancaster and Holmes County with the distinctive cupolas on the roof ridge, were not built with those cupolas for decoration. The cupola is a thermal exhaust chimney. It is the high vent that completes the stack effect circuit. Every cupola on every traditional Amish barn in Pennsylvania is a passive cooling decision made by a builder who understood airflow the way a modern HVAC engineer understands ductwork. Except the Amish builder's solution required no electricity, no moving parts, and no service agreement. The ridge vent of a properly designed passive house can move 800 to 1,200 cubic feet of air per minute through thermal buoyancy alone on a hot day. A standard residential ceiling fan moves roughly 300 cubic feet per minute, using 40 to 75 watts of electricity. The stack effect is 4 times as powerful, uses zero electricity, and has been used continuously by traditional builders for over 400 years. Modern residential construction seals homes so tightly for energy efficiency purposes that the stack effect is essentially neutralized. There is nowhere for the hot air to go. Spray foam insulation and vapor barriers create a thermal envelope so complete that without mechanical ventilation, the house becomes a sealed box that accumulates heat and holds it. We sealed the house so tight to save energy on heating in winter that we made it impossible to cool passively in summer, and now we run a compressor for 5 months a year to fix the problem we created. Your great-grandmother left the cupola open and the north windows cracked and slept fine. Number 6. The Springhouse cooling loop. Not every property has a spring. I want to be upfront about that because I hate when these videos pretend every solution is available to everyone. Some of you are in Phoenix. There is no spring in Phoenix. We will get to Phoenix-friendly solutions in a moment. But in the hill country of Pennsylvania, Ohio, Indiana, and Kentucky, where Amish communities are concentrated, natural springs are common. And the traditional Amish and frontier use of spring water for cooling went far beyond the Springhouse structure we discussed in previous episodes. The most sophisticated version of this system involved running spring water not just through a storage structure, but through channels cut into or beneath the floor of the summer kitchen and along the base of interior walls. The water entered the structure cold, around 50 degrees, absorbed heat from the room, from the stored food, and from the people working in the space. It exited warmer on the downhill side of the building. This is hydronic cooling. It is the same principle behind the radiant cooling systems that luxury architects now install in high-end homes for $40,000 and up. Chilled water circulating through tubes embedded in a thermal mass floor absorbs heat from the space. The principle is identical. The Amish version costs nothing because the water moved by gravity, powered by the elevation difference between the spring uphill and the outlet downhill, with no pump, no electricity, and no mechanical components of any kind. In some traditional farmstead designs, the springhouse sat uphill of the main house, and a channel of running spring water was routed through the cellar before continuing to the springhouse. The cellar stayed several degrees cooler than it would have otherwise. The water kept moving. The cooling kept happening. The electricity bill stayed at zero because electricity did not exist. I know I keep saying that. Zero electricity. But I want you to sit with it, because we have been so thoroughly conditioned to believe that comfort requires a compressor. It can sound almost absurd. It is not absurd. It is gravity. Gravity has been free and reliable for approximately 4.5 billion years, which is a longer track record than Carrier Corporation. Number 5. The Zier pot and buried clay cooling. This one sounds like something from a different continent entirely. And that is because the principle appears independently on almost every continent where humans have dealt with summer heat without electricity. The Amish version and the Frontier version were homegrown solutions that landed on the same physics as a technique used in ancient Egypt, rural Nigeria, and desert India. The Zier pot in its traditional form is two unglazed clay pots, one smaller and one larger, with wet sand packed in the space between them. Food or medicine placed in the inner pot stays dramatically cooler than the surrounding air through evaporative cooling. As water evaporates from the wet sand through the porous outer clay, it pulls heat from the contents of the inner pot. In dry heat, a Zier pot can keep the interior 15 to 40 degrees cooler than the outside air temperature, without electricity, without ice, without anything except clay, sand, and water. Amish families and frontier homesteaders did not use the two-pot configuration as often as they used a variation that achieved the same result at larger scale. Unglazed clay or earthenware crocks buried up to their rim in the earthen floor of a cellar or springhouse, with wet burlap laid over the top, maintained temperatures close to the earth temperature at that depth, and evaporative cooling from the wet covering enhanced that effect. Butter, fresh milk, medicine, and meat could be stored in these buried crocks at temperatures that would be the envy of any modern mini fridge for zero cost, using materials that were standard equipment in any frontier household. The key is the unglazed clay. The porous surface allows slow water transmission. Evaporation at the surface pulls heat out. This does not work with glazed ceramic, glass, or metal. It works because of the specific porosity of unglazed fired clay, a material that frontier families and Amish communities had in every kitchen and cellar because they made it locally or bought it from a potter. Today, you can buy unglazed terracotta pots at any garden center for a few dollars. The physics has not changed. Number 4. The shade tree grid. This one has no permit requirement, no regulatory barrier. No homeowners association can stop you from planting a tree. Well, actually, some homeowners associations can stop you from planting certain trees. Of course, they can. But work with me here, because this is the most accessible piece of the entire system, and also the one with the most thoroughly documented modern science behind it. A mature deciduous tree on the south or west face of a home, planted at a distance of roughly 10 to 15 feet from the wall, can reduce interior temperatures by up to 15 degrees Fahrenheit in summer. Not the ambient outdoor air temperature, the interior temperature of the home behind that wall. 15 degrees without touching the house and without spending a single dollar after the cost of a sapling. The Amish understood this with a specificity that modern landscaping practice has almost entirely abandoned. Deciduous trees, trees that lose their leaves in winter, were chosen for south and west placement because their summer canopy blocks the high, brutal summer sun, while their bare winter branches allow the low winter sun through to warm the south face of the house. The tree solves two problems simultaneously, one in each season, with zero ongoing energy input beyond whatever rain falls. Traditional Amish farmsteads were landscaped with black walnut, oak, maple, and elm on the south and west faces. Evergreens, which retain their foliage through winter, were planted on the north and northwest faces as windbreaks against the cold prevailing winter winds, reducing heating load in the cold months without blocking winter sun. The entire landscaping plan was a thermal management system. Every tree had a reason. Every reason had a season. Modern suburban development removes mature trees during construction because they complicate the building process and then sells the resulting lots as premium properties. The developer saves $3,000 in tree removal complexity. The homeowner pays an extra $800 a year in cooling costs for the next 30 years. Your great-grandmother did not remove the oak tree. She built the house where the oak tree would do the most good. The oak did not cost anything to run. Number 3. The cooling cellar chimney. This one genuinely surprised me. When I first read about it in agricultural extension records from the 1880s, I had to read it twice because it sounded too simple to work. Then I looked up the modern engineering equivalent and discovered it works so well that passive house architects in Europe now install engineered versions of the same system in high-end residential construction, and they charge accordingly. The cooling cellar chimney is a buried pipe or shaft, traditionally a clay tile pipe or a stone-lined channel. It runs from below grade, usually from 4 to 6 feet underground, where the earth temperature is constant and cool. It runs horizontally under or alongside the foundation, and it opens into the living space of the house through a vent in the floor or a low wall opening. At the other end, above grade, the pipe opens to the outside through a shaded north-facing vent. Here is what happens. Outside air, even hot outside air, enters the buried pipe and travels through the section that is surrounded by earth at 55 degrees. By the time that air travels 10 to 15 feet through that earth temperature section, it has given up a significant portion of its heat to the surrounding soil. It enters the house already cooled, several degrees below the outside air temperature, and because it is cooler and denser than the warm air inside the house, it flows along the floor where people are actually sitting and sleeping. The hot air in the house rises and exits through the high vents we discussed in the stack effect segment. The cool earth-tempered air enters at the floor. The house circulates. The system runs itself. The modern engineered equivalent is called an earth-air heat exchanger. It is a PVC or HDPE pipe buried at the appropriate depth and connected to the home's ventilation system with a small fan to move the air. European passive house builders install them routinely. They cost several $1,000s in engineered form. The Amish version cost whatever clay tile pipe cost in 1880, which was almost nothing and was dug by hand in an afternoon. There is a German-Swiss name for this concept in the traditional Amish building tradition that translates roughly as earth breath. The house breathes in through the ground and out through the roof. The earth provides the cooling. The sun provides the stack effect that moves the air. The whole system runs on physics. It ran that way for 150 years before a permit was required to build it. Number 2. Wetted burlap and evaporative curtains. I want to be honest with you about something. When I first encountered this technique, I thought it was the least impressive thing on the list. A wet cloth in a window. Come on, Robert, you can do better than that. And then I looked up the physics of evaporative cooling and learned that a wetted burlap curtain in a window with moving air passing through it can drop the incoming air temperature by 15 to 20 degrees Fahrenheit in dry heat conditions. 15 to 20 degrees. From a wet sack. Hanging in a window, the swamp cooler that you can buy at Home Depot for $200 is a motorized, electrified, pump-equipped version of a wet burlap curtain. The principle is absolutely identical. Water evaporating from a porous medium absorbs heat from the surrounding air. The air cools. If you move that cooled air into a living space, the living space cools. Amish communities in the drier regions of the Midwest, as well as frontier families in the desert Southwest, used wetted burlap curtains hung in doorways and windows as the primary daytime cooling method. The burlap was wetted from a bucket, hung to cover the opening, and re-wetted every hour or two as evaporation did its work. In low humidity conditions, this dropped interior temperatures significantly. In high humidity, the effect diminishes, which is why this technique was combined with the other methods, rather than used alone. The frontier version in the desert Southwest sometimes used a simple frame, a wooden box with burlap stretched across the open face. It was hung in a window opening and kept wet by a slow drip from a clay pot above. The clay pot, porous and slowly leaking, fed water to the burlap at a rate that matched evaporation. A full clay pot lasted most of a day, and the room behind that window stayed cool. There is no patent on wet burlap. There is no service contract on a bucket of water. There is no installation fee for hanging a cloth in a window. And that, right there, is precisely why nobody selling cooling equipment ever mentioned it. Number 1. The integrated, passive system. And here is where everything comes together, and where I want to make sure you understand something important before we close out. None of the techniques on this list are the system. They are each a piece of the system, and that distinction matters enormously because the reason modern people try one of these things, find it partially effective, and give up is that they are using a single piece of a 10-piece system and wondering why it does not do the whole job. Your great-grandmother did not just hang wet burlap in the window. She hung wet burlap in a house that was already thermally massive, already oriented to minimize solar gain, already ventilating itself through the stack effect, already being cooled from below by earth temperature air, moving through a buried channel, already shaded on the south and west by trees her grandmother planted, already drawing dairy and perishables down into a below-grade summer kitchen where the earth held 55 degrees year-round. The wet burlap in that house did not need to do much. Everything else had already done the heavy work. The burlap was the final degree or two of comfort on top of a system that had already cut the heat load by 30 or 40% before you even walked through the door. The Amish did not experience summer as a problem to be solved with electricity. They experienced summer as a season to be managed with knowledge. There is a fundamental difference between those two orientations, and that difference is exactly what the air conditioning industry spent 70 years trying to erase. When Carrier Corporation began marketing residential central air in the 1950s, the campaign was not just selling a product, it was selling a philosophy. The philosophy that comfort is something you purchase, that staying cool is something that happens to you when you pay the right company the right amount of money every month, that the intelligence and effort and generational knowledge required to stay cool without electricity was not wisdom. It was poverty. It was backwardness. It was something modern Americans, with modern appliances, no longer needed to bother with. Within a single generation, the knowledge was gone from most American households. The sleeping porch was closed in and converted to a spare bedroom. The root cellar was filled with concrete and called a crawl space. The shade trees were cleared for the view. The cupola was sealed because it let in drafts. The buried clay pipe was pulled out during foundation work. The Springhouse fell into disrepair because the refrigerator had arrived. Every piece of the integrated system was dismantled, one by one, in the name of convenience and progress, and replaced with a mechanical system that requires a monthly electricity payment to function and that breaks down on the hottest day of the year at 3 in the afternoon on a Friday when no technician is available until Monday. The Amish kept building their houses the same way. In some communities, they received zoning notices. In some townships, the traditional farmstead designs ran afoul of energy codes written by people who had never spent a summer in a stone house with a north-facing cellar and a proper cupola. But the knowledge survived. It survived because the Amish wrote it in their buildings rather than their books, and buildings are harder to erase than documents. It is all still there, in the farmhouses of Lancaster County, in the agricultural extension records of the 1880s, in the passive house engineering standards that rediscovered it 60 years later and gave it a new name, in the geothermal exchange systems that wealthy homeowners now spend $40,000 to install which are doing precisely what a hand-dug clay pipe did in 1890 for the cost of a day's labor. The knowledge belongs to you. It was yours before it was theirs. They just convinced you to rent it back from them at an hourly rate. Here is what I want you to do this week. Just one thing. Pick one. Plant one tree on the south or west face of your home. It does not need to be a mature tree. It needs to be the right tree in the right place. And it will do its job every summer for the next 100 years. For free. Or open 2 windows on opposite sides of your house tonight. One low on the shaded side, one high on the other. And notice how the air moves on its own. Or take a terracotta pot from your garden, unglazed, put a wet cloth over it, and set your butter beside it in the shade. Notice the temperature difference tomorrow morning. Start somewhere. Start with one thing, because the knowledge is not gone. It went quiet, the same way all the knowledge on this channel went quiet. Not because it stopped working, but because somebody got very rich the moment you forgot it. My name is Robert. This is Forgotten American Nature. And your great-grandmother stayed cool in the summer of 1928 with no electricity, no compressor, and no monthly bill. She was not struggling. She was not primitive. She was sovereign. Tell me in the comments which one you are trying first. And if any of you have grandparents or great-grandparents who used any of these, I want to hear about it. Because I promise you, somebody in your family tree knew every single technique on this list. The knowledge did not die. It just went quiet. It is time to start listening again.